Hello coders and welcome to another C# Fundamentals tutorial. Today I'm going to be talking to you guys about loops. There are four major loops. We have the while loop, the do while loop, the for loop, and the for each loop. Today I'm going to be focusing on these three loops, the while loop, do while, and for loop. The for each loop deals with collections of objects such as lists and arrays, and I haven't talked about those yet, so I don't really want to touch on the for each loop just yet, but that will be coming up in a future tutorial. Okay, so we have the while loop. The while loop is going to run while a certain condition is true, and it doesn't enter the loop unless that condition is true, which is similar across a lot of our loops. Actually, all of our loops are going to run only if a certain condition is true, which we set that condition, as you'll see in a minute. Then we have a do while loop, which is similar to the while loop, except it's guaranteed to run at least once. Okay, so an important concept to understand is that just because you write a loop doesn't mean it's going to be activated. The only way to activate a loop is if your condition that's being tested is true. Okay, so a while loop isn't guaranteed to run once. A do while loop is guaranteed to run at least once, and these other loops are not guaranteed to run at least once. Okay. All right, so let's get into it. Let's start talking about the while loop. Well, actually, I didn't talk about the for loop yet. Okay, so to introduce the for loop, we're going to have an iterator, which I'll talk about in a minute what that is. It's going to run with an iterator. It's based off of a closing condition, and we specify an iterator step. So the big difference with the for loop is that you actually, in the parameters of the for call, you specify how big of a step you want the iterator to be. With the while and the do while loop, you have to specify these iterators on your own. So again, we'll talk about it right now. Okay, so what I did was I put each of these loops into a method. And we talked about methods in the previous tutorial, so if you want to learn about these, then go ahead and check that one out. So I'm going to uncomment this method here, and I'm going to open it up down here. Okay, so this is the run while loop method. And the first thing we're going to do is confirm that we entered the first while loop. Okay. Actually, this isn't technically confirmed that you entered the first while loop, but it's confirming that we are running the method. Okay, so then we initialize I to 1, and what we're going to be testing is the value of I. So here we have our while keyword. This entire part is the while loop, and our while keyword is going to be followed by a test condition in parentheses. So you say while parentheses, inside the parentheses is going to be your test condition. So what we're testing is the value of I. Is I less than 5? If this evaluates to true, then we're going to run what's inside the loop contents. If this evaluates to be false, then we're going to skip down until the line right after the loop. So basically, if this evaluates to be false, we're going to print out you have exited the first while loop. Okay, so what we're doing in the logic of this while loop is we're printing out the value of I, and we're incrementing our I iterator. Okay. And the increment operator is plus plus. This is the same exact thing as saying I plus equal 1. It's the same exact thing as saying I equals I plus 1. Okay. So what I'm going to use is the short notation increment operator plus plus. And this increments the value of I. So what's going to happen is we're going to say, is I less than 5? Yes, it's 0. We initialized it to 0. So what we're going to do is we're going to run this code. The value of I is 0. I plus plus. Now I is equal to 1. Let's test. Is I less than 5? Is 1 less than 5? Yes. Okay, console.writeline that value. The value of I is 1. Increment I. Is 2 less than 5? Okay, so this is how this works. It's going to keep going. It's going to keep running this code while this condition is true. Whenever we get up to 5, whenever I is 4 and it prints out I, the value of I is 4. After that happens, 4 is going to get incremented to 5, and then we're going to test. Is 5 less than 5? At that point, this evaluates to be false, and we're going to kick out of the loop. Okay, so go ahead and take a guess at what the output is going to be. Go ahead and pause, and now I'm going to go ahead and show you guys what the output is. So I'm going to go to debug, and I'm going to start debugging. Whenever you're trying to run these programs, always run it via debug. Okay, so go to debug and start debugging. Okay, so let's look at this. If you guessed that this would be the output, then good job. So the output is basically, you're saying the value of I is 0, then the value of I is 1, 2, 3, 4. Okay, again, it stops at 4 because when we increment I to 5, it tests if 5 is less than 5. And since that's false, we're not going to enter that loop logic anymore. And so we have confirmation that we exited the first while loop. Okay, so I have another while loop that I want to share with you guys. So let's comment out that method call and then uncomment this method call, which is the second while loop. I'm going to open up the method content so we can take a look at it. And what I do is, let's look at the while loop first. So the while loop is going to test the condition if input is not equal to exit. Okay, and if that evaluates to be true, then we're going to run all of this logic. Okay, so what I do is I initialize input, and this needs to be initialized to an empty string. So I initialize input to be an empty string, and then I have an int cycles. So I want to keep track of how many cycles the loop has gone through, and I do that by writing that out right here. Again, we have confirmation that we're entering the second while loop, and then what we do is we say while input is not equal to exit, then we're going to run the loop. Okay, so initially input is an empty string, so that's not equal to exit. Okay, so then that's true, and we can run this code. Now, what I haven't talked about yet is console.readline. Okay, and basically this is going to allow us to, the console is going to prompt us to give it some input, and until input has a value, it's going to stay on this line of code. Okay, so you'll see the program is going to stop, and it's going to wait for us to type something. And whenever we type something and press enter, input is going to receive a value, the value of whatever we put into the console. And then when that happens, it's going to come back to the test condition and see if our input is not equal to exit. So what do you guys suspect is going to happen? Go ahead and pause, and then I'm about to give you the answer. Okay, so the answer is this loop is going to run until I type capitalized exit. Because when I type capitalized exit, it's going to say, is capitalized exit not equal to capitalized exit? That's false, right? So what we're doing is literally exiting the loop, and we'll get confirmation of that right here. So let's go ahead and debug and see if that's the output we get. Okay, so we have a number of cycles is 1. So this is our first time. This is our first cycle in the loop. I'm going to type some nonsense string, and since that's not equal to exit, that expression is going to evaluate to be true, and we're going to keep running through the loop. So I'm going to keep typing nonsense here. Okay, so we're on our 5th cycle, and what I'm going to do now is exit out. And the way I do that is I type capitalized exit. Something I want to make a note of, though, is I could type lowercase exit, and lowercase exit is not equal to capitalized exit because of different ASCII values. Okay, so keep that in mind. Lowercase is different from uppercase. So now I'm going to go ahead and exit out by typing that string. Okay, we have confirmation that we exited. So again, I typed capitalized exit, and what happened was this evaluated to be false since these two strings were equal. So this evaluated to be false, and so we got out of that loop. Okay, what would happen if I type capitalized exit here? Would this logic even run? Well, let's find out. Okay, so entering the second while loop, and you have exited the second while loop. So that's what happened there. And that's exactly what we would have expected to happen. And so this is going to bring me to our next loop. As you could see, we did not even enter this logic. Okay, now sometimes you will want to enter the logic of a loop at least one time before you exit out of it. And that brings us to our do while loop. So I'm going to close this. I'm going to scroll up and comment out this method call, and I'm going to uncomment our do while method call. So let's look at these contents. The do while loop is right here, and what's going to happen is we're going to say do, we're going to do this logic, and then we're going to test for our condition. Okay, again, we're going to do this logic, and then we're going to test if the condition is true. Again, if this condition tests to be true, we're going to keep running through the loop. If it's false, we're going to exit out of the loop. So what do? We initialize f to be 0. And in our loop logic, we increment f, and we print out the value of f. Then our condition is f is not equal to 1. So if f is not equal to 1, then we're going to keep running. If f is equal to 1, which in this case, it's the only way that we can exit out of the loop is if f is equal to 1. So if it is equal to 1, this evaluates to be false, and then we exit the loop. Okay, so what do you think is going to happen right here? All right, we have f is set to 0, and then we increment f once, print out the value, and then we test. So go ahead and try to figure out how many times this loop is going to run. Go ahead and pause, and I'm going to say the answer right now. So this loop is only going to run one time, and the reason is because f is going to go to 1, and this is asking if f is not equal to 1. Well, since it is equal to 1, this is going to be false, so we're going to exit the loop. So this is guaranteed to run at least once, even though our first evaluation is going to be false. Let's go ahead and show this happening. Alright, so as I predicted, it only ran once, and good job if you figured that out, because that one was kind of tricky. So we enter the first do while loop, the value of f is 1, and then we exit. Okay, so this is a loop that can easily be accidentally called as an infinite loop. So all we have to do to make this an infinite loop is initialize f to be 1. Okay, and when that happens, f is going to get incremented, and it'll be incremented to 2. 2 is not equal to 1. It's true. So let's run this again. Okay, f gets incremented again. F is 3. Okay, so as you can see, f is going to keep going up and up and up, and it's never going to be equal to 1. This will result in an infinite loop. Let's go ahead and show what an infinite loop would look like. All right, so you can see f is just going up and up and up and up, and this will never evaluate to be false because it's never going to be equal to 1. Actually, that's not true. This technically, let me explain something. This actually isn't an infinite loop because int has a max, and it's something like 2 billion or something. And so whenever that max gets reached, I'm not going to sit here and wait for it because it would take a while. But when that max integer value gets reached, what happens is the value gets looped around. So an integer can be either max positive 2 billion or something, and it can also be negative 2 billion. And so what's going to happen is whenever it gets to that max 2 billion value, it's going to loop around and go to negative 2 billion. And then so that's going to increment and increment and increment, and eventually it'll get back up to 1. So technically this is not an infinite loop, but then again it kind of is because you'd have to wait a really long time for that to happen. All right. So let's go ahead and exit out of this. And let's talk about our final loop, which is going to be a for loop. Okay, so we'll uncomment the run for loop method call. We'll open up the method, look at its contents, and now we're going to talk about iterators. Okay, so here we have our for keyword. This is our for loop keyword. We call this whenever we want a for loop, and then inside the parentheses we have 3 different expressions. The first expression, and each expression is divvied up by the semicolon. Okay, so the first expression is int equals 0. This is our iterator initializer. Okay, this is very similar to how we set int f equal to 1, and then we incremented f here. So int f equal to 1, increment f. This we're doing sort of a similar thing. We're initializing c to be 0, and then we're incrementing c here. Okay. Okay, so we initialize c, and then our second expression here is our iterator exiting condition. So while c is less than 100, this loop is going to run its contents. And what's going to happen is whenever this loop gets down to the bottom of its contents, it's going to increment the value of c and then come back around to test c. Okay, so what's going to happen is c is equal to 0, run these contents, increment c, come back up to test c, come back to test if c is equal to 0 or less, if c is less than 100. So the first time around it's going to say, okay, is 0 less than 100? Yes. Let's run the content. Is 1 less than 100? Yes. Let's run the content. So it's going to go all the way up to 99. 99 is less than 100. So we're going to run the loop. Then it's going to increment I or c. C is going to be equal to 100 at this point. And whenever we test to see if 100 is less than 100, this loop is going to exit. Okay. So this loop is going to execute 100 times from 0 to 99. All right. Well, this loop, or this method is called the Fizzbuzz method. And the way Fizzbuzz works is you have a loop that executes from, typically it goes from 0 to 100 or 0 to 99. And what you do is you test for all the values divisible by 3 So all the values divisible by 3 and all the values divisible by 5. And if a value is divisible by both 3 and 5, you're going to print Fizzbuzz. If a value is only divisible by 3, you're going to print Fizz. If a value is only divisible by 5, you're going to print Buzz. Now, this is a pretty common, believe it or not, this is a pretty common interview question if you're interviewing to be a programmer at some company. And so they're going to ask you this, and they expect you, of course, to be able to do it. And as you advance as programmers, you're going to look back on this and say, wow, why would this be in an interview? Well, the reason this is an interview question is because it is so simple. And the problem that interviewers have or hiring managers have is people will claim to be expert programmers, and they won't even be able to do simple stuff like this. So this is the sort of test that they run on interviewees to sort of weed out the people who can't actually program. So go ahead and take this advice. Know how to do the Fizzbuzz program at least, okay? And this is the way it works. We're doing a loop from 0 to 99, and we're writing out the value of C, and we're testing C against these different values of divisibility. Okay, so it's typically going to be 3 and 5. If it's divisible by 3, you print Fizz. If it's divisible by 5, you print Buzz. If it's divisible by both, you print Fizzbuzz. Okay, so let's run this to see what happens, see what we get. Okay, so let's start up. Let's first see that it only goes to 99, and as you can see, it does. And of course, we start at 0. So the first thing that happens is we look at 0. Now 0 is technically divisible by 5 and 3, because if you say 0 divided by 5, the remainder is going to be 0. So we print Fizzbuzz. It's the same thing for 5 and 3. Then we see 1 is 1 divisible by 3 or 5? No, so we're not going to print anything. We get to 3. Is 3 divisible by 3? Yeah, so we're going to print Fizz. We get to 5. 5 is divisible by 5, so we print Buzz. Skip on over to 15 down here, and you can see that 15 prints Fizzbuzz. That's because it's divisible by both 5 and 3. Okay, so you guys can see how that works. What I really want to talk about now is how this logic works. You guys may have never seen this operator before. It's called the Modulus Operators, the percentage sign. And what it does is it returns the remainder of C divided by 3. Okay, I'm going to repeat that. It returns the remainder of C divided by 3. So if C is 5, let's say 5 divided by 3 is 1 with a remainder of 2. Okay, then what we do is we say if that remainder is equal to 0, then we're gonna do something with that. Okay, now in this case, in the case of C being equal to 5, 5 divided by 3 returns a remainder of 2, so this condition turns out to be false. Okay, then what we do is we say else if C is divisible by 3, so again we just tested that. Then we say else if is 5 mod 5 equal to 0? Yeah, because 5 divided by 5 is equal to 1 with a remainder of 0. Okay, so then we say, okay, let's write Buzz. And what that signifies is that 5, or C, is divisible by 5. So that's how the modulus operator works. Modulus is usually used to determine values that are divisible by a certain number. So keep that one in mind. It's really important. Okay, so that's going to conclude our lesson on loops. Hopefully you guys learned a lot about loops, and you guys can get started writing your own programs with loops. Coming up in the future, I'll try to come up with some challenges for you guys using all of the things that I've taught you in the previous tutorials, so methods, if statements, and loops, things like that. We're going to package all of this into one pretty cool project. So that's the plan for that. If you enjoyed this tutorial, go ahead and subscribe. We're going to be coming out with a lot more things with various programming languages, web development, game development. So if any of that stuff interests you, yeah, go ahead and subscribe so you can get the latest of our tutorials. As always, this has been a Renaissance Coders tutorial, and thanks for watching.